Assalamualaikum and hi everyone. We are from Group 5. We present about refrigerator and heat pumps. Our group consists of 6 members, which is me, Hakimin, Yasmin, Chan, Suhaili, Fatinin, and Alif.
Refrigerators, heat pumps, and coefficient of performance. Refrigerators and heat pumps operate on the same principle but serve different purposes. Both use a refrigerant that cycles between liquid and gas phases to transfer heat. A refrigerator operation includes compression, condensation, expansion, evaporation. In compression, the compressor increases refrigerant pressure and temperature. In condensation, hot refrigerant releases heat and becomes liquid. In expansion, pressure drops, refrigerant cools and evaporates. In evaporation, cold refrigerant absorbs heat from the interior. And a heat pump operation includes heating mode, which is absorbs heat from outside and releases it inside, and cooling mode, which is absorbs heat from inside and releases it outside. As for the coefficient of performance, as known as COP, the COP measures efficiency, which is the ratio of heat transferred to work input. And there are 3 key points of it. First of all, the COP is greater than 1 for heat pumps and is greater than 0 for refrigerators. Secondly, high temperature differences reduce COP. And the last, theoretical maximum COP depends on temperatures.
Okay, next I will move to the performance of refrigerators, air conditioners, and heat pumps. It is usually expressed in terms of the energy efficiency ratio, EER, and also the seasonal energy efficiency ratio, SEER. For SEER, it is the total amount of heat removed during a normal cooling season over the total amount of electricity consumed, while for EER, it is the rate of the removal from the cool space by the cooling equipment over the rate of electricity consumption in steady operation. It is measured in unit BTU, which means 1 kilowatt-hour is equal to 3412 BTU, and thus 1 watt-hour is equal to 3.412 BTU. For variable speed compressor and fans, it will allow the unit to operate at a maximum efficiency for varying heating or cooling needs. Like example, they operate at higher speeds on hot days and at lower speeds on the cooler days, enhancing both efficiency and comfort. The performance of the refrigerator depends on the temperature difference between the inside of the refrigerator compartment's TL and the surrounding environment TH. So the COP, which is the coefficient of performance, will be equal to TL over TH minus TL. As TL decreases, the refrigerator compartment becomes colder, so the denominator TH increases, leading to a smaller COP. So both EER and COP will decrease, making the system less energy efficient. It is because more work is required by the compressor to move heat from a colder area to a warmer area as the temperature gradient increases. So there are 3 advantages of higher SER. So the first one is lower energy cost, the second one is environmental friendly, and the third one is better comfort control. For lower energy cost, higher SER units consume less electricity for the same cooling output, so it will lead to reduced utility bills over time. While environmental friendly, less energy consumption translates to lower carbon emissions, and it will contribute to environmental sustainability. So the last one is better comfort control. So variable speed system in higher SER units provide more precise temperature and humidity control, maintaining a consistent indoor comfort.
Next, we are moving to the heat pump parts, where the definition of the heat pump is to transfer heat from a low temperature medium to a high temperature medium. And there are actually a key difference between the refrigerator and the heat pumps, which are the refrigerator designed to remove heat from a refrigerated space and reject it to surrounding environment. Meanwhile, for heat pumps, it designed to maintain a heated space by absorbing heat from a low temperature source and delivering it to the heated space. So how does heat pump actually work? This heat pump will operate by absorb heat energy from a low temperature source such as outside air, ground and water, and then transfer this heat to a high temperature medium like the interior of a house to provide heating. As you can see the diagram in this slide, we can see that if we place a refrigerator with door open to the cold outside air during winter, the refrigerator absorbs heat from the chilly outside air and reject this heat inside a house through its coils. This process illustrates the fundamental working principle of heat pump, where heat is effectively transferred from a colder region to warmer one. As you can see, this is the diagram flow of heat in the heat pumps, where the cold environment as TL and then the transferred heat labeled as QL, and then through the coil is work done in, and our desired output is QH. So the warm environment, then the TH is larger than TL. So the coefficient of this performance, COPHP, defined as COPHP is equals to desired output, which is the QH, over we require input, which is the W in, and then we will simplify the equation to COPHP will equal to the COPR plus 1. This will implicate that COP of heat pump is always greater than 1 under ideal conditions. So the efficiency of the concentration, which is the ideal condition, is COP can range between 2 and 3 seasonally, where energy loss, some QH is lost to the outside air, reducing efficiency. So the cold climates indicates that COP may drop below 1 when outside temperature are extremely low, and the system switches to resistant heating mode in such cases. There are actually two types of heat pumps, where you can see the left one is actually the air source heat pumps, where it uses outside air as the heat source. Typically, COP is 3.0 under design conditions. There are also limitations where efficiency drops significantly in freezing temperatures. Next, the right image shows us the geothermal heat pumps, where it uses the ground as the heat source, and where the pipes buried 1 until 2 meters deep in the ground. The advantage of these geothermal heat pumps is up to 45% more efficient than air source heat pumps. The COP can be as high as 6 or more. There are also disadvantages for these geothermal heat pumps, where the installation cost might be higher than the air source heat pumps.
Next, what is Clausius statement? The Clausius statement of the second law of thermodynamics is it is impossible to construct a device that operates on a cycle and transfer heat from a cooler body to hotter body without any external work being done. In simpler terms, heat naturally flows from a hotter body to a cooler one. To reverse this process, which heat flow from cold to hot, external work must be performed by using refrigerator or heat pump. So here, you can see the figure 6 to 5, where a refrigerator that violates the Clausius statement of the second law. Next, let's go through perpetual motion machines. Perpetual motion machines are hypothetical devices that can operate indefinitely without any input of energy. There are two categories of perpetual motion machines which violates the law of thermodynamics. The perpetual motion machines of the first kind, it violates the first law of thermodynamics. It produces energy without any input, essentially creating energy from nothing. Perpetual motion machines for the second kind, it violates the second law of thermodynamics. It converts all heat into useful works with no loss or allows heat to flow from cold to hot without any external work. So what is the relationship between Clausius statement and perpetual motion machine? The Clausius statement specifically rules out the perpetual motion machines of second kind. Such machines require the ability to transfer heat from a cooler to hotter reservoir without performing any works, and it's directly contradicting Clausius' principle.
Hi, I will explain about the question that related to household refrigerator with a COP of 1.2 that remove heat from the refrigerated space at the rate of 16 kilojoule per minute. And as you can see in the figure, the direction of the heat transfers is from the cool space to the warm space. It means the heat is being removed. So the question asks us to find the electric power consumed by the refrigerator, which is our work input. So we just need to use the formula or the definition of the coefficient of the performance for the refrigerator, which is equal to the ratio of the QL over W in. So as we can see, the COP ref and also the QL are already given in the equation. So we just need to use the value and substitute it in this formula and rearrange it to solve for W in. So we get W in is 50 kilojoule per minute, and convert it into kilowatt, we got 0.833 kilowatt. It asks us to find the rate of the heat transfer to kitchen air, which is our QH. So we just need to use the energy balance formula, which is QH equal to QL plus W in to find it. So we already know the value for QL and W in. So we just need to substitute the value, and then we get QH is equal to 110 kilojoule per minute. And
for the next question is a question that related to
one house with 3 kilowatt. So as you can see in the figure, the direction of the heat transfers is just vice versa from the refrigerator. So our COP for the heat pump is the ratio of the QH over W in instead of QL over W in. So in this question, it also asks us to find the power consumed by the heat pump. So which is we need to find W in. So just substitute the value given, which is our COP for heat pump and also QH that been given in the question, and rearrange it, and we got W in is equal to 32,000 kilojoule per hour, and convert it is 8.89 kilowatt.